So I am Indranil Ghosh from the School of Fundamental Sciences, Mass University. So today I'm going to talk about Introduction to Socket Bus Network Analysis with Python. So thanks PyOhio for giving me this opportunity to speak at this renowned conference. I will teach how to get open access event data from statsbomb using statsbomb Py, and how to draw a socket pitch using mplsoccer, and how to visualize a bus network for a particular team and analyze the bus network using NetworkX. So you pip install statsbomb. I recommend you to go through the terms and condition of their documentation page of statsbomb. Extract the competitions, and this is what the competition dataset looks like. So we have a competition ID, a season ID, the country name, competition name, the competition gender, the season name, and so on. So here the competition ID and the season ID, we will use this together as an unique ID, okay, to extract the match dataset. Here I used the competition ID and season ID to extract the match dataset, and this is what the match dataset looks like. So match dataset actually. So it has a match ID, the match date. So it's a European Champions League. It was 2017-18 season. It was played between Real Madrid and Liverpool, and Real Madrid won 3-1 to Liverpool, and so on. Like you have the events, then you use the match ID to extract the events. So that's what you do here. You can also see their columns. Okay. Now I'll teach how to draw like football pitch using mplsoccer. So Anmol Durgapal and Andrew Loninson are the one who developed this. So please check them out. So you pip install mplsoccer. We need matplotlib, and we import the pitch classes. We can draw a simple football pitch using this pitch function with capital P. Set the pitch color, line color, stripe equals to true, and so on. Here the X ranges from 0 to 120, and Y ranges from 80 to 0. By default, it's a statsbomb type field. You can also set the pitch color to be black, and you can see a different pitch. And then so there are different types of pitch like Opta, TrackUp, Skill Corner, Y Scout, Metrica Sports, and so on. And if you use them, you will see that the X and Y ranges change. Okay. So you can also draw a vertical pitch. You can draw only half of the pitch. And now I'll dive into visualizing and pass network. So we pip install NetworkX. We pip install Seaborn. And what we do is that from the events dataset, I pick up the tactics column and choose only those rows where it is not an N. So, and like then from that dataset, I only pick up the tactics, team, and type columns. This is what it looks like. The tactics column has so the tactics column is a column for dictionaries where there are one of the keys is formation, and the other one of the other keys is lineup, and so on. So I use this lineup key to extract the player information. So one for Real Madrid and one for Liverpool. And this is what it looks like for Real Madrid. So we see that there is a player ID, his name, his position ID and position name, that's a goalkeeper, and like his jersey number. So same thing for Liverpool. Stored them as dictionaries with the name and with the name of the player and the jersey number, and same for Liverpool. So now we are only interested in the minute, second, team, type, location, pass and location, pass outcome, and player columns of this events dataset. So this is what it looks like. So here the minute of the play, the second of the play, the team which was involved in, the type. Here we see that there are starting 11, half start, pass. So we are only interested on the pass types. Okay. And like the location with the X and Y coordinate of when of the ball, and like of the pass and location, that is the ball where it ended after the pass was successfully done, and the pass outcome, and player, okay, the player who was involved. So what I first do is that I separate them for one for Real Madrid and one for Liverpool, and then I set the pass type, like the type to be only pass, and discard the other types. Okay, both for Real Madrid and Liverpool. So these are the renewed datasets. In both the datasets, we need to add two extra columns named as pass maker and pass receiver. So this is usually done by where the pass maker is set to similar to the player column, and the pass receiver column is the player column, but whose index is shifted by one place in the negative direction. So I do that with using the shift function from pandas. And I set the by default in statsbomb data, if the pass outcome is none, it means like a successful pass, and I extract that like I only keep those passes, the successful passes. So that's what I do here. Then I find out the time when the first substitution took place for Real Madrid and Liverpool, and these are the times. And then I discard all those rows where the minute and second are more than this for both the data sets, because we are only interested on the starting 11 players. Okay, that's what I do, and these are the renewed data sets. Modify the location column and the pass and location column into 4 different columns, that is pass maker X, pass maker Y, pass receiver X, and pass receiver Y. And then I find out for each player of a particular team, I find out their mean X location and mean Y location and the number of passes he created. Okay, so there is a in mplsoccer documentation, they give a very smooth way to do that. Please check that out. And then I yeah, so that's it here. And then I create a separate data set where I find out the pass maker and the pass receiver and how many passes were created from this pass maker to the pass receiver. Okay, so here that's done here, and for both the teams. And then I now will merge the data sets average location for Real Madrid and the pass real, and that's like merging for pass maker data to the average location real. And I do the same thing with the pass receivers case, and this is the ultimate data set for Real Madrid, and the ultimate data set for Liverpool. And finally I replace the player names with their jersey numbers. Okay, and then I visualize the pass networks using the pitch function, and I draw the arrows for the edges with using pitch dot arrows function. Here the thickness represents the weight, that is the number of passes played. And yeah, so that's it. And the nodes location are the average locations, and the node values are the jersey numbers. So one for Real Madrid and one for Liverpool. So now I just use the NetworkX package, but for that I only need the pass maker, pass receiver, and the number of passes. The average locations doesn't matter because location value doesn't matter because we are only now interested on the graph, not the average locations. So I extract those 3 columns into a new dataset, and then I use the NetworkX digraph function, and I add the 2 nodes along with the weights, and I develop this graph. And this is isomorphic to the graph that you just saw with the average locations. Okay, so that's it. This is for Real Madrid. This is for Real Madrid. This is for Liverpool, and we can calculate the degrees that represents the number of passes a node was involved in. Here is the histogram of the degrees. We see that Toni Kroos for Real Madrid has the highest value, and same for Liverpool. We can also calculate the in degrees, the out degrees, and so on. So we can calculate the adjacency matrix for both the cases. We can calculate the Pearson's correlation coefficient. Then we can calculate the geodetic distance between the 2 nodes using a modified weight, that is the inverse weight. And that's a new kind of metric that we actually worked on, and new kind of idea. But if you have some other ideas, please reach me out. So that's it. I discussed this with Sarath Babu, and yeah, that's it. So we can also calculate the eccentricity of a node, that tells how far the furthest player node P is positioned in the pass network. Average eccentricity. We can calculate the average clustering. So for Liverpool, it has a highest value compared to Real Madrid. It means that Liverpool players passed more among each other than Real Madrid. And finally, we can calculate the between the centrality to show which player was actually the most important. Yeah, that's it. So these are the references. And thank you. Wear masks, get vaccinated, and stay safe. Bye bye.